Okay, I think actually, why don't I just do it here? I think that might actually be easier. Yeah, let me do it up here again. So trying this again, let's see if I have basically I want x minus x bar, which is just going to be equal to this value minus already got an x bar here is 3.48, right? 3.48. That's that, and then drag it down. And then y minus y bar is going to be equal to my y value minus my y bar, which is 1.74 for all of them. Oops, what did I do? And I drag them down. Okay, and then let's call this combine. I'm calculating covariance. Let's say the C column is just going to be these two columns multiplied together, right? Okay. All right. So that should be that. And then I'm going to basically, this is my C value. I want the expectation of that with the probability of these things. So let me just do equals to the value of C, multiply its probability with these. That's that. And then let me sum these values. See what is this? That's correct. Yeah, I should have done it with this table as well instead of using a new table. I'm pretty sure I probably messed up some of the calculation when I manually selected. It looks like this number is wrong. Yeah, did I do? Yeah, this one should be. Yeah, that's why. This one should have been 36 instead of 37. Yeah, and I'll probably messed up some other numbers, looks like. This one is wrong as well. This one's 4-1. Is that 4-1? Yeah, that should be 4-1. Yeah, I'm not quite sure why. Anyways, so this number is these two. This is that one. I should have been this box instead of that one because I want the X. Yeah, that's why. Okay, all right, cool. Again, just be careful. I think using the original table in this case would have been a lot better. Okay, cool. Now let's move on to number 9. Okay, so let me put on the answer. Covariance is equal to 0.028. So they're very, very slightly positively correlated. Okay. Let Z be the total number of suburban counties won by the Democrats. So now Z is basically the value of X plus Y, right? What are the mean and variance of Z? Okay, what would the variance of Z be if there are uncertain, if we were certain that UAW is stronger, no longer effective? Okay, so what can we do manipulating these things? Well, we kind of already did that, right? Because I just need to add up a Z column and call that Z is simply X plus Y, right? So this column plus this column, right? It's 4. And looks like I have several columns that contributes to 5, or rows contributes to 5, several rows contribute to 6. So let me combine them. So if I make a new table here, let's see, maybe I'll just add a whole bunch of rows right below this. Or above is fine. Okay, so let's do Z, and we have 4, 5, 6, 7. So these are the possible values, and the probabilities of that 4 looks like is just that probability, right? This is the probability for 4. I want just the value, and then the 5 one is going to be this probability plus this probability, right? And then for number 6, that's going to be 2 of them as well. That's this one plus this one. That's 6. And then 7, there's only one of them, so that's directly equal to this. Okay, now let's see if it sums up to 1. They do. So good. Okay, now we need to get the expectation value. How do we do that again? Well, that's going to be equal to z value times the probability here, and then drag that down, get the EX and sum it up. There we go. There's my EZ. Right. So the total C the Democrats will get is expected to be 5.22. Okay. So EZ equals to 5.22. Now, what is the variance? We need to get EX squared. So let's get the X squared times P here, which will equal to this block squared times this block. Copy formula down. Oops, missed one. And then sum it up. All right, so this is the EX squared. Now I want the var to be equal to, let's say, this number minus this number squared, right? And that's my variance. Okay, so the variance of Z equals to 0.7926. Okay. All right, so this is in the unknowing what conditions we have, unknowing if UAW is strong or not. But what if we are certain that UAW is no longer strong? Well, all that does is we're no longer using the total probability. Instead, we're going to use the weak probability, which is our D6. So all I need to do perhaps is just to replace these values. So this one, instead of, did I do something that changed it? Okay, anyways, this one, instead of using total, now I'm going to use the weak UAW. And then this one, instead of adding up these two, I'm going to add up the weak one. Oops. And same thing here for number 6. No longer just doing that. Now I need to add up these two. Probably easier for me just to type the cell instead of dragging this. And then 7 is no longer that. It's this one. And there we go. Because we shifted the probability to the weak UAW one, now everything should fall into place. This probability still sum up to 1, we're good. And then this is the expectation value. This is the X squared times probability value. And then I'm just going to subtract it. So these two numbers should automatically be updated. And that will be my new numbers. So EZ given weak, let's say UAW like complement. Let's just call it weak. EZ given weak is going to be 4.8, while the var Z given weak is going to be 0.585. Okay. All right, so that's that. Now, number 10. As it happens, the Democrats win only 3 of the northern suburban counties and only 1 of the 4 southern suburban counties. Does this information change your belief about UAW being effective or not? If so, what is your updated probability? So basically, we have to solve for that. So in this case, that jumps to me as a base law problem. So let's see if we can construct it that way. So since we want the probability of, let's say, strong UAW, given that I win 3 northern states and 1 southern state, right? South equals to 1. So this is what we want. And then if I use Bayes' law correctly, that should be equal to the probability inverse them, right? Reverse them. The probability of winning north, 3 north, winning 1 south. I really should use X, Y, because that's what we used earlier, right? So X is north, Y is south. And then given that we are in the strong world, and then multiplied by the probability of we are in the strong world, and then divided by the probability, the unconditional probability of winning x equal to 3 and then y equals to 1, right? So just Bayes' law, nothing too complicated. And therefore, we have all these. The probability of 3-1 in the strong, let's look at the table here. 3-1 in the strong is that. So it's just 0.121. And then the probability of in the strong world, we know that to be 0.6. And then probability, the total probability of in the 3-1 world, which is here, 0.2301. And that's all we needed. And therefore, check that into a calculator. Put the calculator here as well. Actually, I could have used Excel for this, but 0.121 times 0.6 divided by 0.2301. So we have a 31% chance, 0.3155, which is less than what we started with, which is 0.6. That is strong. So this is my updated probability. Does that make sense? Does that make intuitive sense? Well, 3-1 means that we didn't actually win any of the sort of contested seats. Well, in this case, actually, it wouldn't really matter. It's just like we won half of the seats in North and only won 1 seat in the South. That's a pretty abysmal sort of a performance for the Democrats. So therefore, we know then it's more likely that we are in a weak world than in a strong world. So I think that makes intuitive sense to me as well. So that's that. Okay. All right. The next problems involves, I think it's easier, but let's take a look. Normal distribution. The number of votes the Democrats expect to receive in urban counties is normally distributed with a mean of 8 million and a standard deviation of 2. What is the probability the Democrats receive more than 11 million votes from urban counties? That's easy. All we need to do is subtract that number from the mean and divide by the standard deviation of 2. What do we get? That's 1.5. And what is that number? That's the z-score, right? So therefore, I just need to find the probability associated with more than this z-score, right? So what I can do is look up the z-table. Let's just find the z-table. Should be available everywhere. Yeah, let's see if this one gives me the correct z-table. Okay, I want the positive 1.5. This is the negative one. Let's do a positive one. So 1.5, right? So I get a 0.93319, right? I didn't type 0.93319. So that's that. 0.93319. What is there additional 9 here? Okay, so that's the probability of z-score. But that, what does that mean? That means that is actually the probability up to that point, right? Up to that z-score. But I want more than that. So I want to do 1 minus that. Okay, so that equals to, well, calculator. 1 minus 0.93319 is 0.0668. Okay, so that's my answer for the first one. There's a 6.68% that the Democrats will receive more than 11 million votes. Okay, okay, problem number 12. What is the probability that the Democrats' votes from urban counties are within 2 standard deviation of the mean? So if you remember some basic facts about probability or normal distribution, you know that there's a what we call 68, 95, 99.8 rule, right? Everything within 1 deviation should encompass 68% of everything, and then 2 standard deviations should be 95. So immediately you know your answer should be around 95. So let's take a look. So what does the z-table tell us? Well, the z-table tells us at 2 score of 2, I should have encompassed 97 point. Really? Okay, let's see that. So it's 0.97725. Yeah, that makes sense. So 0.77977725. So what does that mean? That means up to 2 standard deviation weight, this side, including everything on the left, is 0.97725, right? So this part is actually 1 minus that. And also, I want within 2 standard deviation, I also want to cut out this tail. So I could figure out 1 tail from here, and then subtract 2 tails. So one tail is 1 minus 0.97725, which would equal to 0.02275, right? Okay, multiply that by 2. That's 0.0465. Yeah, okay. Probably should use a calculator. Yeah, let me use a calculator. 1 minus 0.97725, and then multiply that by 2. Okay, so this is the sum of the tail, right? 0.0455. Okay, right, and that's the tail, but I don't want the tail on the middle part, so let me subtract that. So 95.45%, which is, close to what I expect. So 0.9545 is our answer here. On the other hand, another thing you can do is perhaps you can do like the probability of z equals to 2 minus the probability of z equals to, say, -2, right? Because if we do that, what it means you're doing is you are, sorry, terrible looking, normal. You're getting this side, excluding this 1 tail, and then this also actually tells you the tail on the left. And if you subtract that, then you get 2, right? So we could do that in the z table. The z table, the 2 we already found. This is 0.97725. If you want -2 actually is just 1 minus that. If you know how to convert. But if you want to look up a negative table, you could do that too. So a negative table here is 0.2275. Notice that that's exactly what we got here, right? 0.02. Okay, and if I subtract these two, I'll get the same number, 0.9545. Okay, so that's that. Either way, there's more than one way to get the correct solutions on a lot of these. A lot of these Excel things is a bit confusing, I would say. But once you kind of get the hang, just remember key things. How do you get the expectation value? It's just whatever value you have multiplied by the probability. You get the column of values and then sum it up. That will be your EX. And then the other one, like these ones, I literally squared it and then times the probability to get the E of X squared, sum it up, and then use that number to minus EX squared to get the variance, right? So I use that a lot in this table. In your work, if you don't worry about aesthetics too much, just try to get the answers. And then if you have extra time, maybe you can play around with the aesthetics and then make them into nice looking tables, paste them into your work. That would be great. But yeah, so that's that. So don't be afraid to use Excel. Don't be afraid to use R if you prefer, and don't be afraid to use online calculators or graphing calculators to help you out, because you definitely need that. To calculate all these things by hand is unimaginable to me. So yeah, that's that. Okay, hopefully you guys do well on your midterms. I will see you guys next time.